How you doing, YouTube? We have another bright sunny day, and I'm doing something a little heavier other than all the small stuff I've been doing on my car. Although this is not on my car, this is another project that I've had going on for a while. What we've got here is a Gen 4 5.3 liter LS motor. I had it stashed away for a while. Now I actually got a mock-up engine cradle I'm building for it. So let's unload it. Here we have Gen 4. I know it's a 5.3, although the block is the same for a 4.8 and a 5.3. This is a fairly complete long block that I acquired off of Craigslist, and I've had sitting for a while. Never really had the thought of rebuilding it, but I wanted to mock it up, use it for measurements, and also use it to build a cradle. Let's finish unloading it. Okay, so my plan is to build this cradle. The first thing I gotta do is I'm gonna have to flip the motor upside down. On the LS motor, we have these four bosses where the mount bracket bolts up. We're gonna be using those bosses for our brackets for our cradle. This is what an LS motor mount looks like. It has a mounting plate. It mounts up to the block. Has rubber in between, a rubber mount. And then it has another 3-hole mounting plate that mounts to the frame along with this pin that aligns it into the frame. Completely different than small block or big block traditional Chevrolet engines. This one's torn, as you can see there. What I do with these broken mounts is I'll take these two nuts off and I'll take its plate off. This plate, some of the guys they'll take a flat plate of steel, mild steel, and they'll cut the holes, they'll measure where the holes are and everything. I just figured this takes some of the work out of it. I take that plate already mounts to the LS motor with no problem. Lines up perfectly. Why shouldn't it? It comes from the factory. Then what I did is I took it a step further. I built a jig. I built this jig so that I can make multiple arms and still have the same angles. So what happens is this jig holds one of the mounting plates here. Then I get some square tubing, whatever size I want. This is probably overkill for this one, but... And then I can actually cut the angle that I need, mark the angle that I need, cut it, and weld it. So currently I have two pieces that I've finished up, two of the legs. Mainly tack welded all the way around. Should be strong enough. way they don't move. And like I said, I cut the angle on both of them on the other side. So we'll start with these, and let me bolt them up and so I can show you what I'm really imagining. Okay, at this point I'm going to go ahead and bolt up the arms loosely so you guys can see what this is going to look like. These longer bolts are not the right size, but all they're going to do is help me keep me from covering up a bolt hole. Because once it's all welded up, it might give me a hard time bolting it back onto a motor. Now that I have both legs loosely bolted on, I'm going to put some square tubing on it to make sure everything's squared. First I'm going to put these 2x4s in here like spacers to make sure the tubing is at the right level. I'm just going to use these C clamps so that all the flat faces will meet each other. Tighten them up a little bit. With the square tubing, no pun intended, that should be squared up, at least before I weld anything. I'm going to put this square tubing on here loosely so I can measure, see what size the cradle is going to be. Lengthwise, I decided it's going to be about 2 feet long, and width is going to be about 31 inches. The reason I made it wider is because if the engines run on the cradle, it'll be more stable with a bigger footprint and it won't try to roll over or fall over. So when you're cutting metal, you have quite a few options on how to do it. I mean, you could do old school and go with a hacksaw. You could use an abrasive chop saw or a metal cutting chop saw which has a special blade. You could use an air-powered die grinder or an electric die grinder with a cutoff wheel. What I'm going to be using, I'm going to go a little fancier. I'm going to use a plasma cutter, the Miller Spectrum 625 Extreme. The reason I'm doing that is because it makes less noise, it's fast, and it makes a whole lot less sparks. So there you have it. We have two 28-inch pieces and two 2-foot pieces for the engine cradle base. Well, that's it for part 1 of the Cradle project. Most of the grinding and cutting is out of the way. Next episode we'll be piecing parts together and welding and hopefully finishing up the whole thing. Thanks for watching. Don't forget to comment, like, and subscribe.